Good morning, and thank you for showing up to the GIS T909 presentation. My name is Melissa Thomas. The project that I did was over analyzing future human exploration sites at areas with hydrated sulfates on Mars. So just kind of an overview. I'll be going through the objectives, kind of the reasoning for why I decided to choose this specific project, some introduction on some of the background, methodology, results, and then I'll go through a quick conclusion and some next steps if this research were to continue. So really quick, the objectives were to determine criteria for potential landing sites. There's a lot of different criteria you can choose, like whether it's flat, whether it's scientific exploration. So I focused on areas that are safe for spacecraft landing, and then also have scientific significance that people can study for manned missions, because it's focusing on humans actually going to Mars and trying to study the area. Another objective was also to create maps using ArcGIS that will help answer these questions. So those maps included things like slope, aspect, hillshade, surface roughness, and then also overlay maps like suitability maps to figure out suitable areas for landing sites. And the pretty much main objective was to analyze these maps and narrow down these candidate landing sites to ones that could actually be viable for a manned mission to Mars. All right, so a little overview, I guess, introduction. I'll mention things called hydrated sulfates and hydrous minerals. These are just sediment rich in minerals that have water incorporated into them. They can be found in many places on Mars. This is just the study area that I was working with for this project called Valles Marineris. I'll talk a little bit more about that in a second. But it has a ton of hydrous minerals in this area, specifically hydrated sulfates. And water is trapped within this sediment, like I mentioned. So this can actually be extracted and utilized for manned missions, because resources are kind of a tough issue when you're sending people to a different planet. And there have been studies on Earth where they've actually extracted water from the sediment to use as drinking water. So that's a potentially big, or I guess the biggest reason for doing this, to try and really locate these hydrous minerals and find a site nearby to land. So Valles Marineris, it is, I guess, a huge canyon on Mars. They think that it was formed from when the surface cooled, it cracked and created this giant canyon, and then it widened over time due to erosional processes. They're thinking some involved water, not recently, but way back in Mars history, there was flowing water. They found signs of it. And that is really important because of the hydrous mineral aspect. If there was water that has been widening and carving this thing out, there might be some sediment there that has hydrous minerals within it. This area was also chosen not just because of the hydrous minerals, but also because of the steep slopes. Whenever you're talking about geological processes, steep slopes have a lot of mass wasting, a lot of landslides and rock falls, things like that. Those can be studied. There's also, I guess, the hydrous minerals, which I mentioned, and then smooth terrain for safe landing. This, like the, I guess, bottom of the canyon has a lot of very smooth surfaces where you've kind of had like alluvial fans, like very thin grained alluvium. And so a spacecraft could potentially land there. And that was just that this area has not actually supported a lander or rover as of yet. So it would be great to get some things out there, even if we can't do a manned mission, maybe at least sending some rovers to Valles Marineris once technology has better improved and they can land in areas like this that are kind of smaller and more confined. All right, so the methodology, I put the flow chart that I used throughout this project, but I'll just touch on like the two key points. I showed you that map earlier where it showed the hydrous mineral sites. That was just created using a layer hydrous sites from a different research project and finding point clusters using that tool to kind of figure out areas where there were, I guess, more concentrated hydrous mineral sites. And then for all the DTMs, all the different surface maps that I created, like the aspect, hillshade, slope, and surface roughness, I took a DTM from each area, which I'll talk about in a little bit. And I created an aspect, hillshade, slope, and surface roughness map. Surface roughness took kind of some calculation using the raster calculator. And once I had all of these maps, I then used, I reclassified them to like a 1 to 5 weighting system. Again, I'll talk more in depth about all of this. But I just used these tools to classify and weighted some to create some suitability maps showing the most suitable areas. All right, so determining potential landing sites. I mentioned the cluster tool that I used. This map here on the left shows there were 5 different clusters that I located that at least had like 5 hydrous mineral sites within a certain search area. And it came up with 5 different areas. And so I chose a DTM from each of these areas, a digital terrain model from the HiView data site, which is run by like kind of the camera that takes a bunch of pictures of these things that are turned into DTMs. I collected one from each of those 5 areas, and that was what I used to do all of this like, analysis on. So here are the 5 different digital terrain models that I got from HiRise, which was a little credit down there. We have Candor Chasma, and these are just all areas located within those 5 clusters. There's 1 per cluster. There's Eos Chasma. You also have Ganges Chasma and Melos Chasma. This is just showing kind of the hard, or I guess the digital terrain model without any analysis done to it yet. And then last we have another area in Melos Chasma. One was in a basin. This one is in another opposite area of Melos Chasma. So I mentioned a little bit about the surface maps. I created a hillshade, slope, aspect, and terrain roughness. The hillshade can really show the topography of an area. So if you're searching for maybe areas that get a lot of sun, for solar panels on a spacecraft, or areas that have actually had mass wasting features already occur, hillshade can really help you see details of the topography and details of the landscape, as well as which areas get a lot of insolation or solar rays from the sun. Then there's slope, which shows just the degree of each slope in the areas. And this was important. I kind of used it in 2 different ways. Steeper slopes are great for scientific significance because there's geological processes you can study. But then you can also look for flat slopes if you want to find a flat area to actually land a spacecraft near steep slopes. There was also aspect that shows direction slopes are facing. So going through previous literature, they've actually shown that pole-facing slopes, specifically southward-facing slopes towards the South Pole, get the most insolation just because of the way that Mars is tilted on its axis as it goes around the sun. And that allows for a greater amount of geological processes just because of the interaction of that heat from the sun with the soil and any like CO2 or water trapped inside of it. It causes it to kind of evaporate or sublime and then collapse. So that's pretty important to take into consideration. And then terrain roughness. That's pretty much solely for spacecraft landing. You want smooth terrain so you can land your spacecraft safely without landing on a boulder. All right, and then the suitability maps that I created, I mentioned that I use a 1 to 5 ranking system. I just reclassified each map and assigned 1 for least suitable, 5 for most suitable, and then everything in between. Then I overlaid these reclassified maps to find the most suitable sites. I did this in 2 different ways. It's kind of hard to create just 1 suitability map because you want a smooth, flat surface for landing a spacecraft, but then you want a steep surface steep slopes to study for geological significance. But I couldn't really combine those because they were kind of contradictory. So I created 2 separate ones. There's landing site suitability that used a greater hillshade, it favored a greater hillshade, a smoother surface and shallow slopes, just for landing a spacecraft safely. Hillshade specifically for insolation. You see areas that get a lot of sun for solar panels to power the spacecraft. And then the second map that I created was for scientific exploration suitability. It favored a greater hillshade, again, just because greater insolation. You can get more geological activity on slopes. You can also see previous activity on slopes. Pole-facing slopes, again, specifically southward-facing, so we use that aspect map. And then steeper slopes. So this one is kind of opposite than the landing site suitability map. And I'll show the 5 suitability maps. I did this for each area, so all 5 areas, created both an exploration and a landing, and then kind of correlated the 2. We have exploration suitability on the left, landing suitability on the right. The green is going to show high suitability, and the red will show low suitability. So just a few takeaways from each area in Candor Chasma. We kind of saw that the northern portion of the area is most suitable. There's a lot of correlating green areas that are flat or at least located near steep surfaces, but have kind of lower lying areas at the base of the slopes that are suitable for landing spacecraft. It's also a lot of south-facing slopes that may have greater insolation, more geological activity. We have Eos Chasma here on the right. We found out that the southern central portion of that is most suitable. The slopes kind of fan out to flatter areas, safe for spacecraft landing, but then kind of surrounding it, you have steep kind of cliff sides where you can send someone up to go study mass wasting processes. We have Ganges Chasma. You kind of saw that the western side of the central mound, so kind of over on the left side of the map, that has some steep slopes. It also has alluvial fans that kind of flatten out for a spacecraft to land, but then there are 3 different mounds that scientists could go and study to try and look for, I guess, scientific significance for geological processes. The Melas Chasma Basin, so the northeast corner, kind of up here, as well as a few small areas, could potentially be suitable areas. Melas Chasma Basin was actually not one of the top contenders for a suitable site just because it's relatively flat. You could potentially land in this channel or nearby over here, like towards the bottom of the picture, because it is a flat area and then has steep slopes surrounding you, but it's going to be a tight squeeze. So this one was not actually a great area for landing because of just the lack of smooth surfaces. And then we have another area in Melas Chasma on the opposite side of the chasma. It's a small area on the eastern side that I thought was most suitable, which is just kind of this little blip over on the right side where both areas are green. I also had mentioned with Melas Chasma, so it looks like Melas Chasma in general is not going to be a great area to land just because it's relatively flat, lacks steep slopes. It would be great for landing spacecraft, but not quite great for trying to study processes that are happening. Not only did I correlate between suitability maps, but I also looked at some of the data from all of the surface maps and kind of tried to see some of the mean values and the greatest count to look for what I was hoping for and then figure out which one has the most of the ideal values. So I looked at all 5 sites, looked at the mineral sites, the hillshade values, the slope values, the greatest count of aspect values, and then the mean surface roughness. I was looking for greater number of hydrous mineral sites, greater mean hillshade value, greater mean slope, pole facing, specifically south facing slopes, and lower mean surface roughness. And after looking at all of this, I decided that both the suitability maps and looking at the data from each of those surface maps, that Candor Chasma and Eos Chasma are both fairly good candidate landing sites. Just to start out with, there will need to be more research done down the line to really narrow them down. With Candor Chasma, there's a greater number of hydrous mineral sites, a lower mean surface roughness value, and a greater number of south-facing slopes, which is great. Also better suitable sites because of all of these things. Eos Chasma, kind of similar, there's a little less that would make it a candidate site, but still a high contender. It's a greater number of cells illuminated by the sun and a greater number of steep slopes. And then also higher number of suitability sites out of all 5, I guess, along with Candor Chasma. All right, so next steps, I would hope to obtain additional DTMs that can be analyzed. So I just looked at 5. I was hoping that next time, potentially for future steps, is starting way earlier, getting a lot more DTMs. That would allow for a much more extensive list of candidate landing sites that can then be narrowed down further. It would also be great to measure areas of flat, smooth surfaces. Some spacecraft have a hard time landing on small areas. We can't really do pinpoint landing. So measuring the area to figure out which one is, I guess, big enough to support a landing site. So we don't have to worry about hitting any cliffs or anything like that. But with better technology, we'll also be able to land in smaller areas. And also determining a better weighting system. I didn't quite weight a lot of the suitability maps when I reclassified them. It was just a 1 to 5 system. And then with the weighting, they were all weighted equally. But it would be great to spend a lot of time researching literature to figure out which of those criteria, landing criteria, are the most important, and then creating a much more in-depth weighting system for that. And also expanding the area of analysis. So I just, again, chose those single DTMs, didn't give me a lot of area to work with, but with a higher powered computer that can handle it and more time, it would be great to get kind of, I guess, slope data or elevation data for the entirety of Valles Marineris, and then use that to whittle it down to the best areas closest to hydrous mineral sites and closest to steep slopes, things like that. Yeah, that concludes my presentation. Thank you for listening, as you can open it up to questions.